Hey guys, welcome back. We finished talking about the centroids and we used the integration method, the last few examples. Now we're going to switch to a different type of method. This is going to be called composite bodies. And we're going to use this method when your bodies can be divided into easy to spot geometrical shapes. And by geometrical shapes, I'm talking about circles, triangles, rectangles, things like that. Semicircles, just basic geometry shapes. And the reason why we want to do this is tables have been created like this for these simple shapes. And if you look, let's look at this one right here, for example. This is a semi-parabolic area. Okay, so this is the shape. Now if you look, it's got this C labeled in here. That's the location of the centroid for this particular shape. Now if you notice, it's got these distances here and here going to point C. That gives you your X bar and then your Y bar. Okay, so these things have been created for the different shapes, and with these tables we can break up our body into these same shapes, and then we can use the information in this table to calculate the location of the centroid of our body. So that's what we're going to do in this section. So we're going to be using tables like this. This is the one out of the Hibbler book. These tables are available in any statics book or mechanics of materials or dynamics textbooks, or if you don't have a book, just go to Google and you can search for centroid tables. Now that we looked at those tables, let's look at the equations we're going to have. Since we're going to take our body and we're going to split it up into these shapes, we're obviously going to know exactly how many shapes we have. We're going to have a finite number, and it's not going to be very many. So our equations, we're going to switch from the integral equations and we're going to use summation forms. So for x bar, and this is for lines, for x bar we're going to have the summation of x tilde times L over the sum of L. And remember, L is the length. Y bar is going to be sigma, and then we're going to have y tilde times L over sigma L. Finally, z bar is sigma z tilde L over sigma L. That's for lines and rods. For areas, we will have x bar. Now we're going to have the sigma of x tilde A, which A is your area, over the sum of the areas. So this gives you the total area for that denominator. Y bar, you have sigma y tilde times A over sigma A. Finally, z bar, you're going to have sigma z tilde A over sigma A. Pretty simple equations. Nothing really new there. And the way we're going to structure this is we're going to set up a table when we do our problem. And the table is going to have several columns. First one's going to list the region number. So that's just going to be where we number the shape that we're talking about. Next, if we're using an area, we'll have area. Then we're going to have x tilde. We'll have y tilde. And these tildes, these are the distances to get to the centroid of each of the specific areas or shapes. And you'll see when we do the examples what we mean. Next, you're going to have the area times x tilde, and then we'll have the area times y tilde. Now if you had a line or a rod, you would just switch this out for L, so length. And then here you'd have length times the x tilde and length times the y tilde. Then what you would do is you're going to number your shapes, and then you'd fill out this table, and then at the bottom you would basically do the summation of this area column. Now over here we're going to have the summation of the A x tilde and then summation of a y tilde like that. Okay, so this will be the table that we're going to create for our problems. Let's stop this video here and we'll pick up in the next one with our first example.